right, guys, so today we're finishing up our notes from section 9.7. This is part 2 of that. So we didn't quite finish this part where we're trying to simplify these expressions that were given. So in order to simplify, we're going to have to look at our orange sheet, or we can flip back here to the beginning of section 9.7. Remember, within this section 9.7, guys, you have two parts that you have to memorize. You probably already know these two parts. You probably already know that cosecant is 1 over sine, secant's 1 over cosine, cotangent. You probably know these reciprocal identities. Make sure you don't get these two mixed up, because that's going to really ruin the problem when you're trying to go through it. So remember, tangent is always y over x. So it's sine over cosine. And then cotangent is going to be cosine. Look at that pattern. Cotangent is cosine over sine. So now let's go back over here and see if we can do these two problems of 7 and 8. Anybody think they know what we should do on this when we have these two terms? Factor out a 2. So when I factor out a 2, I'm left with secant squared x minus tangent squared x. And while I'm at it, I might as well do the replacement here. I'm hoping you're starting to have these memorized, but maybe not. But let's see. The tangent of negative x, is that equal to the tangent of x or negative the tangent of x? Negative, good. And what about the cosine of negative x? Which is that going to be? Positive or negative? Positive. Think about it, guys. If you have a negative angle and you go into the fourth quadrant, is it going to have the same sign as the one in the first quadrant for cosine? Yes, cosine is our x value, so this is going to be positive cosine x. All right, so we've got this. Now we need to know what secant squared x minus tangent squared x is. Does anyone know that one off the top of their head?
1.
It is 1. Here's the reason why. This orange sheet is something you'll be able to use on your test when we take it. These are our Pythagorean identities. If I have secant squared theta minus tangent squared theta, that's going to leave us with just 1. So all of this is just 1. So 2 times 1 is going to be 2. I'm going to pull the negative right here. And now I'm left with tangent times cosine. Well, when I'm trying to simplify this, I'm trying to get it down into a single trig function. So I want to have either just sine, just cosine, just tangent, and I have 2 right now. Any ideas on what we can do? What do you think, John?
Change tangent to sine or cosine.
All right, I think that'll be a good choice. So we have negative 2. If I write this tangent as sine x over cosine x, and then it's getting multiplied by cosine x, what would now happen? Right, so these cosine x's would now cancel, so we would have negative 2 over sine x. That's still not the most simplified version, though, because what's 1 over sine x? Cosecant. See, what we want to do is we don't want to have fractions when we're simplifying either, if it's possible. So this would be negative 2 cosecant x. So that's another name for this original function. In fact, if we were going to graph this function, you could either type all of this into your calculator or just that. So you can see why it's very helpful to know the simplified version. Let's try number 8. All right, negative sine of pi over 2 minus theta. Maybe you know this now, maybe you don't. If you don't, you look at your paper. The sine of pi over 2 minus theta is the same thing as what? Cosine theta. The negative's going to stay, so I'm going to have negative cosine theta. Okay, can't do anything else yet. Secant of negative theta. Well, secant is the reciprocal of cosine, so it's going to have the same rule as the cosine function. So if cosine of negative theta is positive cosine theta, what is secant of negative theta? Positive secant theta. All right. We have 3 trig values here. We want to get it down to 1. Any ideas? What's up? Okay. Common denominator may not be quite the best route. What do you think? I think that's a better choice. So what I'm going to do is I'm going to think of this as negative cosine theta times 1 over secant theta for this little part here. The reason for that is this cosine is getting multiplied by 1. And this times 1 would still stay the same, and then there's a 1 under this. So this is equivalent to what we had. This is just a little bit easier to see. So if you look at your reciprocal functions, those are what you have to have memorized. So do you know 1 over secant, what that's the same as? Cosine. So now I'm going to have negative cosine theta times cosine theta, still minus the sine squared theta. What are we going to have here then? All right, so I'm going to have negative cosine squared theta minus sine squared theta. I want to get this down as simplified as possible. Anybody know what to do? Factor out the negative. So if I factor out a negative 1, this would now become positive cosine squared. A negative divided by a negative is a plus sine squared. What's another name for this? So what's our answer? Negative 1. So all of this stuff here is just the same thing as negative 1. All right? Okay. Let's go down here now to number 9. Now we're trying to find all exact solutions in this interval. Okay? So what I'm going to have to do is I'm going to have to think of how to start the problem. And typically, what do we do on a problem where it starts like this? Get it set equal to what? 0. So I'm going to go ahead, I'm going to take this over. So I'm going to have 2 sine x cosine x plus radical 3 cosine x equals 0. Look at this. I have a term here and a term here. What can I do with those 2 terms? Factor out what? Cosine x. So I'm going to factor out cosine x. If I factor that out of this term, what am I left with? 2 sine x plus what? Now we have it factored. When we're solving an equation, our whole goal is to get it factored, because if I have 2 numbers that are multiplying to be 0, how's the only way you can get a 0? If you're multiplying by what? 0. So it has to be true that either cosine x is 0 or 2 sine x plus radical 3 has to equal 0. Okay, now we've done this kind of problem before. This is review. I want you guys to figure out what these are. What are the answers? There should be 4 answers. So on this one, we're doing cosine of our angle has to be 0. On the unit circle, cosine is the x value. Now listen, guys, this gets confusing. On the unit circle, x represents cosine. In this equation, though, x is representing the unknown angle. Okay, that gets confusing for people. Those are two different x's, right? So I'm going to be looking on the unit circle. Where is the x value 0? What did you guys put? Pi over 2 and 3 pi over 2. Great. Now, solving this one, you had to take over that radical 3, and it becomes negative radical 3. You had to divide by 2, so you get sine x equals negative radical 3 over 2. We're trying to find what is the angle that has a sine of negative radical 3 over 2. On the unit circle, what is sine representative of, x or y? Y. So if we want sine to be negative, which quadrants are we going to be looking at? 3 and 4. Did you guys get the angles? What they should be? 4 pi over 3 is correct. And 5 pi over 3. So our 4 answers then are pi over 2, 3 pi over 2, 4 pi over 3, and 5 pi over 3. Those are the solutions to this equation. All right, let's go on to the next one. What are we going to do on a problem like this? Can't factor out a secant. You have to get a set equal to 0. So we're going to have 3 secant squared x plus 5 secant x minus 2 equals 0. Now, I'm going to see if this can be factored. Here's what I do. I multiply the first and the last number, and I get 6. Are there numbers that multiply to be 6 that would subtract to give us 5? 6 and 1, right? There are numbers. So as long as that happens, that this would be the case that it would work, that means it can be factored. So I'm going to have a 3 secant x and a secant x. Now, you can either have 1 here and 2 here, or the reverse, 2 here and 1 here. You have to decide. Do you want 1, 2, or 2, 1? 1, 2, let's see. So if I do 1 first, 2 second, my outers would give me a 6 secant x. My inners would give me a 1 secant x. I want to get a positive 5. Can I make that happen and still get a negative 2 when I multiply 1 and 2? So which one of these do I want to be negative, the 1 or the 2? The 1 would need to be negative. The 2 would need to be positive. Let's check it out again. That's going to give me a positive. That's going to give me a negative. Negative 1 times positive 2 is negative 2. Yes, we're all good. All right, so now we're going to keep going. What's this going to end up being? Secant x equals what? Take it over and divide. 1/3. What's this going to become? Secant x equals what? Well, for now it's negative 2. Secant x equals negative 2. Okay, now we're not really familiar with secant, so we're going to change these into cosine. So if I change this into cosine, what's this going to turn into? And if I change this into cosine, what's it going to turn into? Now, is it possible for a cosine to have a value that's 3? No, what do all of our answers for cosine have to be in between? Negative 1 and positive 1. So this is not going to even have a solution. All right, cosine x equals negative 1/2. Can you guys just visualize the unit circle, figure that out? What 2 quadrants, first of all? 2 and 3, right? Okay. What's the reference angle if I want cosine to be 1/2? Not 45. 60-degree reference. Okay, so now think of a 60-degree reference in those quadrants you guys said. Good job. All right, very good, guys. So you're going to work on this worksheet. I'm going to do one problem with you. I want to find one. Oh, it's just exact. I wanted one that was not going to be exact on the back, but did you guys come across any on the worksheet that you thought were really difficult so far? 3? Okay. All right, I'll do 3 and 15 for you. Okay, guys. Number 3, let me show you the did anyone figure out what the trick was on this? How can I, first of all, when I have secant, sine, sine, cosine, I want to get rid of the secant and make it a cosine. If I'm going to make that secant a cosine, where is it going to have to go? Into the denominator. So this is really going to be 1 over sine x cosine x. Always want to do that first. I'm trying to get that to equal cotangent. What do I do now? Look at these two fractions. What am I going to do? Common denominator. I can't subtract until I have a common denominator. So I'm going to have to multiply this by what? Sine x on top and on bottom. So now I have a common denominator, so I can write the numerator all as 1. Sine x times sine x is sine squared x. On the bottom, I've just got this sine x cosine x. Once I have that common denominator, it's just going to stay whatever it is. What is 1 minus sine squared x? Cosine squared. So now I'm going to have cosine squared x over sine x cosine x. What's going to happen? One of these cosines, this is cosine times cosine. So one of these cosines is going to go, and that's going to go. So now I have cosine x over sine x. What's that the same as? Cotangent. So I think if you couldn't get this, it's because you didn't work on that secant first. Get rid of that secant first. All right, let's look at 15. What was the problem here? Whenever I see a 1 and I see something squared, I'm looking at my Pythagorean identities. What's another name for 1 plus cotangent squared? Cosecant squared. So this is cosecant squared times sine theta. So what's another name for cosecant? 1 over sine. So this is really going to be 1 over sine squared times sine theta. Oops, theta, not x. So one of these, this sine can cancel with one of these. So I'm left with just 1 over sine. I'm trying to get this no fraction and just a single trig value. So what's it going to just be? Cosecant theta. How many people got that on their own? Okay, good. All right, guys, so you're supposed to work on finishing this worksheet. I want you to do all of this front part. You need to get them all finished through number 15. I will just let you do the odds in this section down here, the 16 through 27 part. I know, I'd set up through 15, 1 through 15. Okay, so on the front, you're going to do all of it. Front is all. Up to here, you're going to do all. And then on the back, just odds in this section. There is this extra problem down here at the bottom. I'd really love for you to try it. It's pretty complicated, but I'm sure some of you can figure it out. All right, guys. Good.